Here we go. Thanks for being here for the Unit 10 Logarithms Practice Test. So just want to give a special shout out to a student that I've helped lots during the year, Rooster. His parents or himself brought by an amazing BB-8 LED light up thing for my room. So thanks guys, appreciate it. All right, here we go. So showing you with by hand, with a graphing calculator, and with Desmos for the first 4 problems. So that negative right there is going to indicate probably negative growth. So that's awesome. So denote the negative growth there versus regular growth because there's no negative there. Growth. There we go. Okay, awesome. So let's see here. Oh, so if there's a number in front of the equation, that's going to be your horizontal asymptote, right? Invisible barrier. If there's not a number in front, you have to assume it's 0, which is just going to be along the x-axis. And so for negative 2x plus 2 power, so with the graphing calculator, I feel like it's a little bit easier. So you go to y equals, you go to negative 2. Make sure you use the ouchie negative, not the other one. And so negative 2 to the, so you do the caret symbol, and then x plus 2. And then graph, there you go. So push trace, that'll give you need that. So you need the y-intercept, which is at 0, negative 4. That's one of our test answers, 0, negative 4. So that's going to be down here. So we have 0, negative 4, and then it goes along the asymptote and then down. Awesome. So you need the horizontal asymptote. You're going to need negative growth, what it represents, as well as your y-intercept for each of the first 4 problems. Then we'll do the matching graphs at the end. Let's see here. So doing this by hand, I would do an xy table and choose values for x like negative 1 or negative 2, doing it by hand. So negative 2, negative 1, 0, 1, 2. And specifically the 0, because that's always, right? The y-intercept. So if we plug in 0 in, it's going to be 3 to the 0 plus 2. And anything to the 0 is just a 1. So 3 to the 0 is just a 1, plus 2 is 3. So this indicates we are going to have a y-intercept at 0, 3. Nice. If you plug a negative 2 in there, well, now you're going to start getting some crazy stuff going on. So that's going to be 1 over 3 squared, which is going to be a 9th. Wow, so 2 plus a 9th, so just 2 and a bit. So that's going to be back to up 2 and a bit. The next one will be a bit more. You plug in a 1, you get 3 to the first power is going to be, 5. So over 1, up 1, 2, 3, 4, 5. We'll put a 2 in there. So 3 squared is 9, plus 2 is 11. That's way off the charts. So this is going to be exponential growth. Nice. Check your answers. So now you pause me. And you try this one. You try this one. No, you try this one. No, you try this one. I'm waiting. Got to do this on your own. Then you check your answers with my video, right? Now I will let you know there's a trick there. Shout out to Gigi. So she told us that for Desmos, if you're trying to do number 1, right? If you're trying to do number 1 for Desmos, then here we go. So you actually have to do something weird, right? So you have to actually use parentheses. So you go negative 2, a to the b gives us the exponential. And then you got to do parentheses, else it's going to not work for you. And so if you use parentheses, then it works. If you don't use parentheses, then watch what happens. Yeah, it just shifts it down 2 and gives you the wrong graph. So be careful, make sure you use parentheses, then you can do your x plus 2. There we go. So we have a y-intercept again at 0, negative 4. So that was using Desmos for number 1. That was using Desmos for number 1. So e to the x power, so e to the x, so that's going to be found right here. So you go second ln, or second e, to the x power, there it is. So again, that was second ln, right? That gives us the e. So second e right? Can you see it right there in blue? There it is. Okay, so we're going to go ahead and do to the x power. And look at that. It's just exponential growth at 0, 1. So we go 0, 1 for our y-intercept. And this is going to be exponential growth. There's no horizontal asymptote specifically like a number, so let's just assume it's 0. It is going to be growth. There we go. So whenever you have a base, right, which is your rate, your base or your rate, remember, is less than 1, like 1/4, which is 0.25, which is less than 1, then it's going to be decay. Don't forget that. It's going to be decay. So there is no horizontal asymptote. Well, there is. It's just at 0. And so this one's going to decay. So if we plug in a 0 in there, it's going to be 1/4 to the 0 power, which 1/4 to the 0 power is just 1. There we go. Oh, wait a sec. Yeah, just 1. Cool. And if you go a little bit to the left and a little bit to the right using the XY table or using your calculator or decimals, it's going to look like this. Nice. Okay, so number 5 is expanding and condensing. So don't forget with expanding and condensing, if you have a division, it becomes subtraction. Or if you have multiplication, it becomes addition, right? Expanded. And so we are going to expand our log into log base 2, but we're going to do it for each variable. So we have a variable x, and we have a variable y, right? X and y. And then division becomes subtraction. And that's just our answer. Woo! Not too bad. So log base 2x minus log base 2y. Now for number 6, don't forget to distribute the 2 through first. So you get log base 2, right? So log base 2, x squared over y squared. Watch out, lots of distractors on the test. So log base 2, so it's going to be x squared minus, not just y squared. No, that's wrong. Remember, you got to put another log in there, log base 2y squared. Circle your answer. No, that's actually wrong. And the reason why that's wrong is because those powers, those exponentials, can expand more and become big old 2's in the front. And then we put those big 2's in the front, and that'll give us our full correct answer there. Fully expanded. So division becomes subtraction. And multiplication, distributed. Don't forget to distribute. So u squared, and then 2 times 2 is 4, so v to the 4th power. And then, do you remember what times becomes? So times becomes addition. So we're going to do ln of u squared plus ln of v to the 4th power. And then we'll move our powers in front. So we get 2 ln u plus 4 ln v is our answer. Nice. Let's use a little bit of green. Yeah, go booger green. Whoa. Okay, there we go. So number 8 is log x times the square root of y to the z power. Do you remember what the square root is? So for example, the square root of 16, do you remember, is 4. But guess what? 16 to the 1/2 power is the same as the square root. So square root is 1/2 the square root. So that means for number 8, and on the test, you want to do log x, right, times y z to the 1/2 power. And we can just split those up each individually because we're expanding them both. Whoa, it's supposed to be a z. Okay, right? And so, yeah, log x times y to the half times z to the half, because both of these, right, this is 2, so it's the 1/2 power there. Okay, then addition. So multiplication becomes addition. So then don't forget this is base 10. If they don't say it is base 10, but I think on the answer it'll just be log. So log base 10x, or just log x plus log, because we have a 10 base kind of number system, right? So log base 10x plus log, y to the half plus log z to the half. And then last but not least, you're going to move those powers in front to finish it off. So our final answer there is log x plus 1/2 log y plus, whoa, 1/2 log z. Is our answer. Nice. So that's how we expand. That's how we expand them. Sorry, that's supposed to be a plus and a 1/2. There we go. Okay, so, condensing. So condensing is going the other way now, right? Going the other way. So we start off with subtraction. And we want to condense now, right? So that means like make smaller, right? Make smaller, condense it. So if they have 2 logs, we want to take it down to 1 log. But it's really tricky, though the first step actually needs to be, so first step is move numbers in front into exponent position. Exponent position. What do you mean, Newbold? Well, if there's a 36, you want to move it in front like that, so 11 to 36, or 5 to the 6. So in this one, we want to move the 3 there and move the 18 there, right? And so do the exponents first. Then after that, we're going to go ahead and our 2 log base 6s are going to become 1 log base 6, right? 1 log base 6. So then we have bring down our x to the 3rd power now. And then what does subtraction become when we're condensing, going back the other way? Division. And then we'll bring down our y to the 18th power. And that's it. Woo! So make sure you do only 1 log. So I know students sometimes do 2 logs and get that wrong. So just do 1 log now, because remember we're condensing to 1 log. So again, we're condensing to 1 log, so log base 6. And then we're going to have 11 to the 36 subtract becomes divided by 5 to the 6. Because our exponents went into the front. See, easy peasy lemon squeezy. Okay, so number 11 is a little bit weirder, so we definitely want to help you there with number 11. So it's kind of tricky. There's an invisible 1 times with that ln 11 and with that ln 7. And so this means we have 1 divided by 3, right? Which is a fraction. So we're going to have ln of 12 plus 1/3. Get it? ln of an 11 plus 1/3 ln of 7. Right? And so now those are actually exponents. And since those are exponents, we're going to go ahead and move those into the exponent position like that. Move it into the exponent position. And now, what does addition become when you're expanding? So addition becomes multiplication. So we're going to go ln, only one of them, only one. There can be only one who wants to live forever. Yeah, Highlander, I am immortal. I have inside me blood of kings. Hey. Anyways, so you should watch it. Cool show. ln of 12. So addition becomes multiplication. And so then instead of bringing on the ln, those go away now because we condensed to 1 ln, only 1 ln. So it's going to be ln of 12 times 11 to the 1/3 power times 7 to the 1/3 power, bringing it down. And then that becomes ln of 12 times, and it turns out the 1/3 power, you guys, is just the cube root. Just the cube root. Right? That was just a little example there I did with x. So this will be 11 times 7 together, because they both do the 3rd power, as the cube root, right? 1/3. And so 11 times 7 is 77. So it'll be the cube root of 77. So ln of 12 times the cube root of 77 is our answer. Okay, make sure you put the powers in front, right? So a squared, so we're going to do log base 2. A squared times, because addition becomes times. And then that went over there as the exponent, and then b cubed. And that's it, lemon squeezy. Okay, let's see here, next one. Ooh, number 13. So please write the following exponential as a logarithm. Hopefully we fixed this on Canvas already with the correct answers. So basically, if you have like, I don't know, like a 2 to the third power, that's going to equal 8. So to turn that into a logarithm, you do log base 2 of the solution 8 equals the exponent 3. So when you have letters now, it's going to be log of the base still, which is 2 or A, of our solution, which is C, and then equals the exponent, which is B. So there's our answer. Now let's go the other way, because that was exponential to log. Now we're going to go log back to exponential. And so go back to exponential, we go like this. We still use our base, so 2 to the 5th power, and then equals 32. Awesome. Nice. And that's our answer. Now 15 and 16 are trickier. Those are tricky. So basically you have to get the same base, right? And then you can log both sides the base, and that cancels the base. But first, let's get the same base. So 25 is not the same as 5, but 5 times 5 is 25, which is 5 squared. So we're going to change 25 into 5 squared, okay? So we have 5x squared plus 8 equals, and then 25 becomes 5 squared to the x plus 8. Now don't forget, an exponent to an exponent, you have to multiply, right? Exponent to an exponent, we multiply. So we're going to go ahead and get 5x squared plus 8 equals 2 times x is just, so 5 to the 2x. And then 2 times 8 is 16. Nice. So now, again, to undo those base 5s on either side, you're going to go ahead and log base 5, right? And that's going to get rid of base 5. So now we're just left with what's the exponent, which becomes regular now. X squared plus 8 is no longer an exponent because we got rid of the base 5, equals 2x plus 16. Oh no, how do I solve this one? I can't get all the x's on one side, numbers on the other, because there's a squared there. Well, that squared indicates that we have 2 solutions. And 2 solutions means that you're going to have to get everything on the same side. And do what? Then factor it. So we're going to go ahead and minus 2x over to this side. There's nothing to combine with. So it's just going to be x squared minus 2x. Then we're going to minus 16 over here, minus 16, and negative 16 plus 8 is a negative 8. There we go. Okay, so now that can factor into x and x. And then what are factors of 8? You notice, factors of 8. That's right, 2 times 4 is 8. And then remember, the sign of the middle term always goes with the larger number. So it's going to be a negative 4 and a positive 2. Then you set each of those equal to 0, and we get 2 solutions, right? We minus the 2 over here, and we get x equals negative 2. And then we add the 4 over here, and 4 plus 0 is just positive 4. So we get a positive 4. Now definitely plug them in to make sure they work. So 4 squared is 16 plus 8 is 24. And then put a 4 here. And so that looks like it's only 12, but actually, remember, it's going to be a 2 with the 12, which you multiply those, and you get 24. Because 2 times 12 is 24. So 4 works. You can put a negative 2 in as well, and you get negative 2 squared is a positive 4. And 4 plus 8 is 12. And then over here, put a negative 2, and you get 8 minus 2 is 6. Well, 25 to the 6 is the same as 5 squared to the 6, which 2 times 6 is 12. They work. Cool. Okay, so you try number 16 now. Pause me. You try number 16 on your own. And watch the next video and see if you got it right. Thanks for watching. Coming back to number 16 next time. Please turn the cassette tape over to side B. Video 2, here we go. Woo!